I thought this was a great starting point. I know that many of you know Git already, and hopefully there are some things in here that will be new to you. I feel like every time I work on a new project with someone, I learn some other new Git thing, and my students are often teaching me new things or making me use certain things. And it's it's a big piece of software. It can do a lot of things. It's a little bit complicated at times, so there's always more to learn. So I picked out a few things for us to think about today, and then also the GitHub system as well. So what is Git and GitHub all about? Well, one of the things we want to avoid is kind of crazy nonsense like this, right? I don't know if anyone's ever seen someone have a file structure like this. I've certainly seen some of my friends like as undergraduates with their essays structured like this. Or we want to avoid situations like this. People emailing code around and saying, don't work on this because I'm going to work on it now. So Git is a version control system, and it's all really about sort of having a way of tracing back the versions of files, of code perhaps, and also understanding authorship and collaborating together and enabling people to work at the same time on the same project. So we want to avoid this kind of stuff, and that's where Git and GitHub come in. Found this quote, which I thought was a lovely way to start as well. It's easy to shoot your foot off with Git, but also easy to revert to a previous foot and merge it with your current leg. So it gets at something of the sort of version control and rewriting history and merging things together idea. Some of you will sort of get the joke, and others may be a bit like, okay. And we'll kind of, by the end of it, that joke should be pretty clear. So what's the plan today? We're going to look at the basics of the paradigm, look at the way that Git structures things for us and how we interact between Git and GitHub. GitHub is this online sort of almost like sort of collaborative social network side on top of Git that's now run by Microsoft. It actually has its own implementation of Git inside, so it's technically a different piece of software, but it integrates together, gives us the web side of things. So we're going to look at a few lesser known corners in Git, I think, look at a few advanced techniques, because I'm kind of imagining that most people use Git already somewhat. That's my guess. And if Git is completely new, then hopefully there'll still be enough of the background that we'll sort of go over, but you might need to sort of go more slowly over that background again another time. So we'll look at what GitHub brings on top of that, the sort of extra organizational aspects, and we'll also do some practice. So this is a workshop, this is not a sort of lecture. So I've got some worksheets with a little exercise for everyone to do, which will start sort of a bit before the break, and you can sort of have another look at as well during the break. Okay, so the central organizing principle of Git is the idea of a repository. A repository is where we keep our files, and it's how it organizes everything about the history of those and all the changes. And we're going to understand things in terms of having a local repository and a remote repository. The local repository is, say, what I have here on my laptop, and the remote repository is connected to that somewhere else. Perhaps it's on GitHub or on my university GitHub server or GitLab or Bitbucket or something like that. It's a remote version of the repository, and these two things are linked semantically. They have some connection, and we can link them together and transfer changes between the two. Now, of course, Git's also about working collaboratively, so there might be many different local repositories with many different people, different teams, and then the remote repository acts as a kind of synchronization point where all the changes can be brought together as the hub and then disseminated out to the spokes to the other local repositories. It's also possible to have multiple remote versions of multiple remote repositories connected to different locals, but we won't really use that today, but that is also possible as well. So lots of different topologies around. Please do just interrupt me at any point. can make things interactive. If you want to ask questions or say, hey, I do things in this way, then that's great. So, at the starting point, how do we actually make one of these things? Well, one thing we could do is start with GitHub, and GitHub can create a remote repository for us. So we can, let me just adjust my order of things there. I've got my GitHub account set up, and I can go and create a new repository online, and click there and go through the setup, and that creates a remote repository. I'm going to use this one that I set up already today. So I can start by creating a repository on GitHub, and then what I want to do is bring it down to a copy locally. So I can do that by using the git clone command and taking the web address up here. I can take this one, or if you click here, you can also get the HTTPS address here, which ends in .git. Just do this one. And so what that has done is create my local copy of the repository. An alternate approach, which I won't demo, is that I could first make a directory locally. I could go into that directory and run git init. That creates a fresh local repository within that directory, sets everything up there. So that pops into existence. And then I could go and connect that to a remote repository by creating one on GitHub, like we had before, and then adding this connection between the two on the local side by this command, git add remote origin, and then the web address. So that's a way of telling the local, okay, your remote repository is this one over here on GitHub, and origin is just the name of that remote repository from the perspective of the local here. So we're already starting to get into all of the different commands that you can access through the Git top level. Yes?
I think you have the wrong order of the command. It should be git remote add.
Oh yeah. Git remote add origin. Yes, thank you. Yeah. Okay. Brilliant. Okay. First typo. Not too bad. It's only 10 minutes in. Thanks, Casper. So what actually goes into a repository, there's sort of more going on underneath. We're going to see this broken into three parts at the moment. You've got your working directory, which is your file system. And then there's something called the staging area, or also called the index, which is kind of like an intermediate point. And then there's the repository, which is like what Git understands as the code. What does it have? What is it tracking? What is it doing to sort of track changes on? So I'm going to go into my repo here, and okay, there's not much in there. I'm going to make a new file using the touch command. That's just a sort of Linux thing. And maybe I can put some things in there. Use my little editor. So at the moment, this file is something that Git is not tracking the changes for. If I write git status, just make this a little bigger, we can see that it tells us some stuff, and it tells us there's this untracked file called intro. So it knows it exists, but it's saying, well, I'm not tracking anything about it at the moment. But what I can do is now add that using the name of the file, and this means it becomes a tracked file, and it goes into the staging area. So if we look at the status again, we'll see that we've got this, it's now changed, gone green, this is now in the staging area. So we're saying, okay, we're thinking about putting these changes into the repository. We've got them ready to go. And then from there, we can do a commit. That's taking those changes and saying we're committing to them, they're going into the repository now, they're going into the history of this project. And so the command is git commit. You have to provide a message that explains about what that is, with this -m, so you can put something in here. And now that change has been registered in your repository as having happened, and that's now in your history. Now that's still on the local side. This change is only visible to me, and then we can make that available to others. We can push it to the remote, so that transfers it onto our remote repository. So now if I go onto GitHub and have a look on here we go, there's the intro file, and we can see, if we look at the list of commits, there was some other stuff I was practicing yesterday. Here's the top one, we've got that hi everyone on top there. So what we've got now is a history of versions in our repository, and maybe if I go and edit this again, I can do some more commits. Oops, forgot to add, so I can add by the file. We'll see some other cool things with add in a bit. Git commit and push. So as we're doing that, we're creating commits, and they have a name to identify them, which is this long hexadecimal hash. And you can see all of those if we look at git status. Git log. The top one there is the commit that I just did with the message be nice, has this long name by the hash. And we call this, this is also referred to as the head commit. It's like the one that's at the front of my history. And sometimes it's also referred to as the tip. You can use head as the name for it as well within Git. And so, as we go on, we make more commits. We're sort of growing this linear history. Oops, sorry. So we'll also refer to one of these chains as a branch. And as we'll sort of visit later, these things can be not just linear, but they can be more like a tree. So the branch terminology is apt. It's like a path from one point out to a leaf. Now these hashes are kind of long and a bit annoying, but they're kind of used to access things. So if you're just using the command line all the time, you can for example do show and then copy a name of one of the commits and it'll tell you what was in that commit. So you can have a look at what was there before. It's like a sort of unique address for that commit. You can also just use the first 7 digits. So you can see that within Git. You see here there's just like a short version of that commit hash, and so you can also use that in order to do things with it as well. So that can be a little bit easier to work with. But I can also do show head. That shows us the changes from that last commit. So, a little bit of an aside here about these Git commit messages. The general advice is to be very descriptive with them, but also concise. Here's a comment from XKCD about commit messages. It's easy to get into this trap of just sort of writing commit messages that don't mean anything, or don't mean very much. And this is very common in academia. Some of my colleagues, we're working on a paper, and it's just each commit is called update. And it makes it very difficult to know what they've been doing. So you have to then go and look at the things and say, okay, what did they do? And if it's, oh, we've got some problem here, some problem was introduced. When was that problem introduced, and who did that? Then you have to get into the Git blame pathway to try and find out who did it. It's much easier if you've seen the commit messages going by and you see, okay, they did this and they did this, and this is what people are working on. So if one of the things that Git provides is a kind of accountability, traceability, then having commit messages that actually explain roughly what's been done is very useful. And then that helps you trace the ideas back and understand what the changes are. So adds feature X would be a good one. We're going to see that we can link with other parts of GitHub using these sort of numerical references. So we might say we fixed bug number 152. And GitHub provides a nice way of then linking things together based on the fact that you mentioned that number if there was a 152 bug in its issue tracker. We'll see that later on. Maybe you write a commit message, and like me, you write a commit message and you think that is a bad commit message, or you see the horrible typos that you put in it. So you can rewrite the message for that commit before. Better to do it before you push it. It's harder to fix once it's pushed. So maybe you did something, and you. Oops. So I'm going to throw in a different version of git add here. I'm going to do git add-u, which adds everything that was modified, everything that's been updated, and I do some message. And I think, no, that's very bad. My collaborators will not know what's going on, so I can do -- amend, pops me into the editor, the default editor that I've got configured here, which is Vim, I guess. And I can change it to something useful. And then I can push. So a thing that I learned a while ago, which I think is very neat, and this is going to be in the practice, is another variant of add, which is git add-p. So what that lets you do is, let's say I have a load of other stuff here. Maybe you go and you edit a load of files. Maybe you make some new file. Like this, and we want to add those things in. So git add-p gives you a view where you can see all of the changes that you've made. Maybe you've had a really long hacking session and you've touched lots of files, you've made lots of changes all over the place. Git add-p then lets you go through and say, at the level of each file, shows you what's been changed and lets you actually split those apart into smaller chunks. So maybe you want to then break down what you've done and say, okay, this is how I solved this thing, I did this bit and this bit and this bit, and it makes it much easier to understand then for someone else in your team rather than this commit that changed 30 files and 200 lines of code and it's called do X. If you've broken it down, it's easier for then people to review and look through. So git add-p gives you this little thing, it calls them hunks, where they're like chunks of your edits. You can go through. Sometimes it gives you the chance to split them apart if they're quite big. In this case, it hasn't, but I can do a manual split by pressing E. It gives us this little view, and we can say which lines we want to be included or not. So these ones with plus, it's saying are going to be added here. Then what I can do is, if I want to not do some of those, I can just delete them from this thing here. And so that's just added one line. I can probably show that. I can't remember how to show that. But now I can do a commit message. And then when I do another add, I've now got those remaining lines there that I can put into their own commit. So this I found is super useful, trick that I didn't know about for about 10 years. Git add-p. Often, you've been working hard, you've done lots of stuff, lets you break it apart into smaller, more understandable chunks of a commit. Anyone else got any useful git add tips? Simon?
Well, the -p, the patch option also applies to git reset, which is with the opposite sense.
Yeah, git reset. Thank you, Simon. Yeah, so I'll talk about git reset in a second, but the -p is really meaning patch, and it lets you edit things as a patch and sort of configure what's in that, and that does work in different places. The reset is like the opposite of the add, and you can also do things selectively. Thanks. Yeah, I'd actually never done that before, so hey, I learned something. So git reset. There we go. So git reset is useful if maybe you add something you think, no, I actually don't want to add that. So I do some stuff, and then I add that, and then I think, no, actually I don't want to add that thing, or I'm not sure, maybe I added some stuff and I went away and got a coffee and I think, oh, I don't really know what I added, I want to sort of go back. What git reset will do is move everything out of the staging area back into the working directory. And as Simon said, you could do git reset-p and you get this same view and you can sort of choose which things to take out of the staging area. That could be especially useful if you've added loads of different things to the staging area already and you don't want to have to sort of pull it all back and then go back through the process of adding things in. You can selectively move things out. Git reset will do a bunch of other things as well. It can also help you take a commit and roll that back as well, which you can do like this. So say you've gone all the way through and you've committed it, it's there. You can do reset, and this little thing here, head ~1, means the head but -1. So you want to take that head commit and roll it back. What it does is it moves everything back into the working directory. If I use git log, I can see I don't have that commit anymore. And if I look at my git add-p, git status, I can see that I've got that Wednesday file untracked now. So we've gone back to how things were before we did the adding and the committing. So I find that super helpful to be able to sort of roll things back like that. Yes?
Isn't it safer to use git revert in this case?
So git revert you can use with the working directory staging area sort of point, I believe. So I think you can use git revert for that. Oh no, or is that restore? That's git restore, I think. Okay, so Ivo, do you want to tell us about git revert?
What I understood is git revert will create a new commit which removes whatever you added between add -1 and add. So you can.
Yes, I remember now. Yeah. So if you do a revert, I can do.
I think this can create a dangling. What is it? What do we call it?
Detached, yeah. So if I do a revert, then what? Yeah. So revert is a way of sort of doing this with accountability. It's like, okay, I wanted to revert something, but I want to still keep it in the history that I did that thing, and then I undid that thing. So if I do a revert, and I look at the log, I can see that I put I had that commit where I committed that file and those changes, Wednesday information, and then I have this other commit, which is going to remove that stuff, which then explains, no, I wanted to revert that, and it tells you which one it reverted. So they do different things. I mean, revert is good especially good if something's also gone into the remote already. Like if you've already pushed things to the remote and it's gone out to your collaborators, you did some work and then you later realized, no, that work was bad, or introduced a bug, or it's not what we wanted to do, but we still want to understand what happened, then git revert is brilliant for that, because you've got this accountability, you've got this commit that explains what happened. I use reset at the more like local level of, oh no, I didn't want to do that. And before I go and tell that to all my collaborators, let's just go back a bit. And I sometimes do that if I do a big commit of everything, and then I think, no. What I should do is split that up so that the team who are looking at that in 5 hours' time when I'm asleep can understand it better. So I'm going to chunk it up into some smaller pieces. Great, thanks so much for that. I forgot to do a git revert thing, so that's brilliant. Any other comments or questions? Cool. Okay, so what we haven't done is actually pull some changes yet. So say that someone else goes and works on this repository. So I'm going to add some stuff here. Maybe this comes from another collaborator. This is still just me on here. So this is me making a change via GitHub, which you can do. It's not typically recommended apart from maybe things like small text files. Then what I want to do then is bring down the changes that have happened to someone else or that they're on the remote, and I can do git pull. Now, here I've got something popping up saying that we're going to create a new commit is going to be created and has a message, a merge message that's appearing here. So what's going on there is that I'm getting a merge between changes that I had locally and changes that happened remotely. So it creates this additional commit for me to show that merge point between the changes on the two different places. If I have a look at that, then we can see that it contains both, I can't remember deleting that line, but okay. It contains both lots of changes together in one commit. Now, this is fine, but I think this approach is often seen as not ideal in many cases. So what the git pull is doing is really two commands together, something called git fetch. Git fetch is just like download all of the information from the remote repository and have it here within the Git infrastructure, but it's not actually actioning any of it when it comes to my current branch. Git merge then takes all those remote changes that it has now as a sort of locally cached, and it applies them to the working directory. However, it often creates this extra merge commit, and over time that can be a bit frustrating because it sort of muddies the history of your repository. If there's all of these merge commits in there, sort of adds some extra noise. If it's every time that someone has to do a pull and maybe they've got some local changes, you're creating a merge, it adds a lot of extra things into your history, which it turns out is not really necessary. There is a way of avoiding this situation. And also, if you're looking at the merge commit, it actually, on its own, it misattributes changes. So let me push what we've got here. I'm going to push that merge commit. So we can see that we had this commit down here that was about revert punting details. And we have this one here that was about the updating the intro. And now this merge commit has both of those things in together. It doesn't have my deletion there. But what I think in this case it's done something slightly different. But what it will typically have is all of the changes in one place. And so it's sort of like a little bit obscure because maybe I'm not the person that actually made those changes. But looking at that commit, it will say, Dominic did this, even if Ben was one who went and made some changes. The merge commit will just put all those things together. So it just creates this noise within the repository. And there's a way of getting around it using something called the fetch and rebase approach instead. So git pull is a combination. It's fetch, then merge. Fetch, then rebase does something slightly different. So let's look at this pictorially. Let's say you've got these, you've got your local and your remote. They've got the same history. Sorry, I shouldn't use the laser. I should use the stick. Because then people can see it online. You've got local history and the remote. And say, on my local, I do some changes in green there, and someone does some other changes that go onto the remote in red. Now, I can do this command here, git pull dash dash, it's supposed to be 2 dashes, git pull dash dash rebase, which is the same as doing git fetch, then git fetch, then git rebase. What that does is it sort of moves my local commits out of the way, takes the remote commits and puts them at the tip of the branch, and then brings my commits back out and puts them on top, like this. So it doesn't matter about the actual sort of temporal order of the commits. they're not time dependent. Could be that this red one happened after these green ones. But it has this new order now. It doesn't need to create a merge. It's as if I did these green changes after the red one had occurred. So let's have a look at that in action. It also gives you a chance to deal with any conflicts that might happen before then. So I'm going to modify a bunch of these files. I think that will do. Make some commits here. Oops. Yeah, I want all those things. My add-p, it's just what I do these days. So I've got my commit over here on the local, and I'm going to do some changes on this side. Let's say I change this file and say, there. So I've got some remote changes and I've got some local changes. Rather than doing git pull, I'm going to do git pull -- rebase. Now, because some of these changes conflict, I'm in this kind of zone where I can deal with that conflict. It's put the red commits, the ones that happen remotely, up the tip, and it's saying, okay, it's now like you're trying to do these green ones on top, but there was a conflict. You need to deal with that before you move on. This is great because there's a little bit of rebase commands I need to deal with here. So it's saying that there was a conflict on the Wednesday file. Let me open this in, actually just going to open this in Visual Studio Code because I like the way it colors the messages. So where is the conflict? We can see that the current change, the change that I did locally is there, and the incoming change has sort of, we did it on the same line, right? So it thinks it might be a conflict. In this case, I'm going to say, that's fine. I'm going to accept both changes, have them together. Visual Studio Code provides this little interface, but of course I can just delete these little meta lines myself and say, okay, that's fine. That's how I want things to be. Then what I do is I add those files that I changed, use my normal add pathway, and then I do a git rebase -- continue. And now everything is fine. I've got this history that has the update from the remote that happened here, and it has my green update on the top. That's this one that's gone over here. And that now also includes the fix I did as part of that change. So if I look at the show of that, you can see that I have my changes. That's my changes to the intro file, and my changes to the Wednesday file are there as well. And I don't have to have an extra commit that deals with the merge conflict. I don't have to have a special merge commit. There's no sort of noise generated there, and I can do a git push, and now everyone has the same view of things, and we didn't have any bonus merge commits or anything like that. Makes it much cleaner history. I find it definitely simplifies things when you're collaborating, especially with lots of people. And once I got the hang of this technique, I found it made things a lot smoother. Okay, so that was the pull -- rebase pathway. Okay, so just a few more things before we get towards the exercise. So branches, we've been working with a single branch. It's like a baby sapling with one thing coming out of the ground so far. But we can use the idea of branches. We have multiple branches, and this is really good for organizing code when we're adding new features, fixing bugs. This is going to help us work collaboratively. So the git branch command tells you all the branches that you have at the moment. And these have names which you yourself choose. The default is the main branch, and that's where I am now. That's marked with a star. So this is our branch. Now I can create a new branch. I'm going to call this one feature. This bit here is just a name I'm coming up with. And what that does is it takes that branch and it essentially creates a copy of it with all of that previous history there as well. Now I'm still on the main branch at the moment, but if I do a checkout, then I move where I am, move the star. I'm now looking at code in the feature branch. And here I can then go and do some changes. Maybe I go and update some code. I'm going to call these commits D and E, and go and do some stuff there. So let me actually do that. So we were here. So let's say that I want to add a new feature to a piece of software, add some new functionality. Okay, here it's just some information. So I'm going to go and add Thursday, Tuesday. So I've done some commits on here. Then I can switch back to the main branch. And maybe I do some more stuff here. Then I can do a merge. This is a merge that we definitely want to do to bring in the changes from the other branch. So I can do a merge like this. And what that's going to do is take the changes. This diagram is not super accurate, sorry. It's going to bring the D and E commits down into the main branch as well, but it will also create for me a merge commit if it needs to. It didn't need to in this way because I actually didn't change anything on the main branch. But if there's been some other changes on the main branch, it will make one of those merge commits. But I think that's a useful kind of merge because it shows you that some new features being merged in here, and now we've got all of our changes down on the main as well. So we can see that Tuesday info. So when it comes to working with GitHub, there's some nice features that come along with using branches as well, which we'll see momentarily. Okay, so we've seen a whole bunch of stuff so far. This is like a quick reminder, status, log, show, add, reset, commit. It's kind of easy to get overwhelmed with all of these things, but I think over time and practice, you sort of get used to it. And loads of people use Git in the world, so if you get stuck, you can usually Google things. So let's start looking at Git and GitHub together. It's very fashionable on the internet to use these AI image generator things. So as a small, I was playing with it with my kids, and all of the images it generates are super creepy, but I thought that was kind of a good one. So I think the things like GitHub and GitLab, Bitbucket, they all provide kind of similar functionality, provide a really useful then interface on top for sort of organizing projects on top of Git and using the Git infrastructure. So we're going to do another branch kind of deal. Actually, no, first we're going to do a fork. So what is a fork? So I have another account over here, and I'm going to find that Tuesday repository. And what I'm going to do is create a fork of it. So a fork is when you take some existing repo and you make your own copy of it, but it maintains some connection between the two. So say I DAO29 saw this project and thought, oh, I want to contribute to that. I'm going to create a fork. Now, I have my own copy of it on this DAO29 organization, my other profile. It's taken that repository and copied it, but we have that link still there. It's not that I cloned it to my local machine and then pushed it up to my own GitHub account, which would then not have that link. The fork enables us to see where this thing came from. It came from originally this other place. So it keeps the connection. It's important for sort of understanding then how different things are related. And on over here, I can maybe I can do this all from GitHub. That will make things a bit simpler. Let's do a new branch. So I'm going to add some things in here. So I've got my changes now over here on this other remote repository that's a fork, and then GitHub gives us this useful thing here called compare. It says compare and pull request. So a pull request is saying to the owner of the original repository, hey, I've made some changes, please could you pull them onto your version of the repository. And it gives us this nice interface where we can see, okay, what we're doing is taking the branch called new stuff on the Tuesday repository, and we're going to sort of merge it in over here to the original repository on the main. And this is a great chance to explain what we've done in a way that's semi-coherent. And this is a great chance then to explain all the things that you've done, explain what changes have been made. There's also various widgets at the side. So for example, you can add a reviewer who's going to review those changes before they get merged in. You can add labels, and that can help understand what kind of change it is, and various other things here. So now over on the original account of repository, I can see this pull request here. It tells me, okay, someone wanted to make an enhancement. I can look at that, maybe discuss with them. Maybe there's some things that I want changing. We're going to see later maybe some tests that passed that the GitHub Actions have told us aren't working. We can have some interaction there until we're happy, and then we can do the merge like this, put in some information, and now that closes the pull request and merges all of those changes into the main branch here on this repository. So we've got everything there. So I think this is quite key when you're then working in when you're working in teams. One way of organizing yourselves is to have a central repository that everyone has edit access on, and then you sort of all work against a single remote repository, which is fine. Then you should use your branches to organize your work. So if you want to add something new, then the standard advice is create a new branch, do your work there, and then make a pull request to merge it back. Or you can have the other approach where you fork the repository onto your own local account first, do your work there, and then again do a pull request back. So having the forks means we've got a single point of origin. There's all of this connection back to the original repository so that we can do a PR and give a chance for those changes to be reviewed, rather than just like smushing it in straight away. If you've got some sort of process within your team of like making sure that other people are reviewing the work, having a bit of team involvement, then that's the PR. The pull request system is great for that. And later in the week, Ben and I are going to be talking about code review as well. So the general advice is don't copy fork, but also only fork if you really actually anticipate contributing to the project. So it can get a bit complicated if you've got loads of forks and your fork was really just because you wanted to play around with your own configuration. Well, that doesn't really need a fork. You can just clone it and play around on your local machine. I think within a project, it's much easier to understand what's going on if the forks have some meaning. They're sort of there because someone actually wanted to contribute back and make a pull request back to the original repository. So yeah, follow up with the PR. Okay. So another super useful thing here on the GitHub interface is issues. This is an issue tracker. You can log problems or maybe things that you're working on. So I can create a new issue. Maybe assign some people who are going to work on that, and include some information, again, labels, is it a bug, is it documentation, enhancement? You can create custom labels as well, and that helps make things much easier to understand in the issues when you've got lots of things going on. And then that's a really great way for you to then discuss as a team who's going to do things, keep track of problems, keep track of new features, and as we saw before, we can link this in with then our commits. So I'm going to do some work over here. Oh yeah, I've got my merges, that's great. So maybe I do some stuff and say some things here. I can say working on number 3. Oh, I didn't add. So now when I push, that's going to be linked together. We can see that that pops up automatically that we were working on this problem. Haven't finished it yet, but maybe I'm doing some work on it. So just by using that number, GitHub links those things together. We can have a look at that commit. Makes it easier to understand, attribute what work you're doing and how that contributes to different things that you've got going on. And the nice thing is that if you use the words fix, close, what's the other one? Fix, close, and there's some other words that you can use, and their conjugations, then it will automatically close the issue as well. So maybe I do something else. Closes number 3. Then when I push, we'll see that issue has now been moved to the closed state, and with that last commit there. And so that no longer shows up in my issues. So that's a nice way to sort of automatically deal with things as well. But be warned, maybe you want to use those words then carefully, otherwise it creates this automatic change of state. Resolve, that was it. Fix, close, and resolve. Like these special words that GitHub will understand. I think I'm going to not talk about tags and releases actually. I think I'm going to save that one for another time. We can talk about that one offline if you want to know about that. But it's maybe it doesn't take that. A tag is a way of sort of associating some other information with things. So maybe I've got sort of a release version of something. Let's call it version 0.5. Creates a sort of marker within the repository that we've reached a particular version. I can push tags by doing git push --tag, and on GitHub we can see that then underneath the releases here. We've got a tagged version. It sort of says, okay, at this point, at this commit, we were calling it this particular version of the code. So that's really useful if you're doing releases and you're saying, okay, I'm making this available to the world at this point, or maybe you're doing a paper and it's, okay, this is the version that we use to create the figures for this paper. This is the geophysical letters 2001 submission that we did at this point here, and that's really useful then if you want to put it on Zenodo and be able to link back to it in your paper. So this is the version that was used to create, to produce this paper. So that's really useful as well. And you can put in more information here. You can build a release from a tag by choosing, for example, here and putting some more information. And yeah, that's really good for releases and making things clear which version, which particular point of the code you actually use at this point. Okay, so didn't take too long to explain that. Okay, so the last little advanced thing is the idea of a stash. That's like another kind of area that you have available inside of Git. It could be a place to put changes that you're working on. You can sort of move out of the way. And this is quite common with, say, you're doing some work and you're doing various things. I'm running out of creativity now. And then someone pings you on Slack and says, oh yeah, I fixed that thing, by the way. Or you see it come up, oh, that person fixed that thing. Oh, actually, I really want to get their changes. I really want to draw that down. So I'm going to add something on here quickly. But I'm sort of midway through doing something, and I don't want to commit it yet. So what git stash does is sort of just moves it out of the way for the moment into this sort of other little area, and then I can do the pull, and then I can do git stash pop. It's a sort of a stack, so that brings that back off the stash, and now I can keep going and working on my changes that I was putting down here. So it just sort of moves out of the way, brings stuff in, move it back on. So very useful. Find myself using that when I'm in those kind of intense periods where I'm working with the team, we're trying to get something released or write a paper, and it's people are doing lots of stuff, and oh yeah, I do want to see their change, but I'm doing something at the moment, so stash it, bring their changes in, and put the stash back on top. Okay, great. Okay, thanks everyone. So hopefully, I've seen lots of issues and pull requests. Of course, I made a mistake on my exercise sheet, where you may have noticed, where on my exercise sheet it said there'd be one file, and on the Git there are two files, but people have worked around that. So let's just have a little look at the way that people have used things. So lots of issues added on here, which is great, explains what's going on, so that's very nice. Let's look at a few of these. So I'm going to pick on Ben because he's on our team, so I can pick on him and not feel too bad. Okay, he's put a little message on there. So the nice thing about what Ben has done here is that he's created the issue, and then he's made a commit. He's made the commits to reference the issue, so we can see that they've popped up there automatically. It's this kind of linking everything together, so the team can understand what's happening. So he's referenced issue number 5, add cookies as favorite food, add Ben Orchard to the names, and then he's even linked his pull request now to that. So we've got the pull request over here. So you can see that in the pull request, he's also mentioned the issue here. So this again provides the link. GitHub is scraping the data, having a look at it. It's hyperlinked there to the issue, and we can see from the issue that it's connected everything together. Now, because I already merged a few people's things in, and we're all editing some small files, we've got some conflicts, so you can resolve those here. Let's just have a look at the interface we've got. You can see that sort of lots of people editing the same file in the same line, so I'm going to just resolve those by deleting that meta information which we saw before. This is us saying we want both of those changes together. And so I'm going to mark this as resolved. So this is GitHub's interface for resolving conflicts. And we've got another one here. That was from the names file. So I'm going to keep both of those names in. And I'm going to make a thing that explains that merge. So that should show up in the PR as well. Yeah, there we go. Thanks. You can see my commit in there. And as we're going to see later on in the week, you can use this interface here for doing this code review process, having a discussion if it needs to be had. And then, okay, I'm going to merge the pull request here. So it's going to bring all of those changes together onto our main branch. You see that goes a nice purple. And that will also close the issue as well. So because of that linking, so it does it all for you, which is really nice. So make use of those numerical identifiers to connect everything together. And now we see we've got Ben's commits in there. So I won't bore you by going through and doing all the rest. It's the same for all the others. The last bit of the exercise, which you can try later, then is to take, if you've done a fork you can go and update your repository now. You should have a thing that says that the remote has been updated, so you can pull those changes to your fork, and then you can pull those down to your local repository. So that's just practicing the other direction. The first exercise was sort of pushing everything up, now you want to draw everything down. So have a go at that later, in a break or at lunch, and you can chat to me or one of the other team if you want to discuss that more. So any sort of last questions about that exercise or what we've done there? Yes?
What's the difference between the word resolve and close?
What's the difference between the word resolve and close? So where did we see resolve? Let's see over here.
So you said earlier that GitHub has some terms that it can recognize and
Oh yes, yeah, right, inside of the commit messages. I don't think from a GitHub point of view they're seen as the same. So if you say that you resolved issue number 5, then it will close that issue automatically in the interface. So as far as GitHub's concerned, they do the same thing: resolve, close, and fix, and their conjugations. So if you say it closes it or it closed it, or, but maybe I think perhaps they roughly mean the same thing in English. Yeah. But this is a different kind of resolve. There's conflicts, and we want to resolve those. Yes, Chris.
Should you point out that in the actions that you take, though, there is a difference, because you can close a pull request without merging it?
Yes, thank you. Yeah, so you can decide who can I do this to and not feel too bad. No, I won't do it to anyone here, but
You can reopen it afterwards.
that's true. Okay. So forgive me, Gia. You can close the pull request, which means that you're not actually actioning that work, but you can reopen it again later. So maybe someone's tried to do something, and eventually you've sort of decided, oh no, we don't need to do that anymore. We did it in a different way. So it can be closed. It goes into this closed state, but you can reopen it. And underneath the pull requests view, you can go and see the ones that have closed. Nothing's lost. It's all there again for you to have a look at. Okay, nice. So just to kind of finish things up then, obviously there's a lot of other things we could say. In an hour and a bit workshop, there's tons of other things you could do. We can't fit everything in, but hopefully this has kind of gone over the principles, given you a refresher on the basic paradigm, and if you're already a bit of a Git user, shown you some new things as well. Now, the other thing I wanted to mention at the end is some of the other stuff that GitHub adds, which is its project management features. And again, this links in with the whole issues and pull requests paradigm. So a project is something that's associated with an organization or with a personal account, but then it can be linked in with particular repositories. So I'm going to go over here to my top level and click on projects. I'm going to create a new project here, which gives me this view. And there are sort of two styles depending on how you orient the information. So I'll just talk you through one, give you a bit of a demo here. So I'm just going to create this table view and call it Information Improvement Project. And here, what you're seeing is a view that you can collect together issues from. Actually, you can do it from multiple repositories into this list here, and you can also create new items as well, which are kind of seen as draft issues. So I'm going to add an item here. So I could search on sort of the Tuesday, and I could mention some of the issues on here. Oh, actually, no, sorry, it was on the, let's do the Cambridge, the Git training one. Oh, I can't see it on here. It's fine, I'll do the Tuesday, and I can reference an issue or a pull request. So if I go back over to the Tuesday repository, and make an issue here, maybe add some more information about that. No, that's not what I wanted to do, sorry. Okay, Hash Tuesday, okay. And then I can control all of the things I could control before about who's going to do this work, and I can give it a status. Maybe it's in progress, maybe it's to do, kind of tells me about where it is at the moment, and there's all kinds of other bits of information you can add onto this side as well. So for example, you might add, you can create new fields, and maybe there's a date. Maybe you want to say, okay, we definitely need to get it done by this point because, hey, we're going to write this paper, so when is it due? And so I've added that to this list here. I can say, okay, we're going to submit on Monday the 26th, so it has to be done by then. And there's other various kinds of fields, there's like, iteration. That's if you're doing a style where you're working, this is this sort of agile programming approach where you have iterations, and you say, okay, we're going to work on features for 2 weeks and then review it, and so on. You can assign it to an iteration in this way. There's various other, so okay, we're going to do iteration 1 between these dates. There's all kinds of things you can add here to explain, to kind of link into your team culture. Maybe you have some way of prioritizing things as well. We can create a text field, priority, and so on. So it's a way of collecting together the tasks that you're working on as a team, assigning roles to them, other bits of information, when do you want to be done by, the priority, and collecting those together as issues and pull requests related to, could be more than one repository, so there could be multiple things you're working on. It could just be associated with one particular repository. So here, if I now go and look at the projects for the Tuesday thing, I can explicitly add the link to the information improvement project. We can see that here. That gives me then access to that board. So this is a nice way of drawing together what GitHub already provides with the issue system, with the pull requests, provides kind of an extra layer of information on top for you to organize the tasks and make sure you know who's doing them, when you're doing them by, and also having discussion then via the normal systems. So this is giving us access to that issue, but might have a discussion. Add more various bits of information in, and then all of the other automatic systems, like when I close things, will also work there. You can add another view, which you can put in the board mode. This is a style called Kanban boards. It's just to basically transposes the information, and you can see, okay, we've got that in progress. Okay, maybe we had to stop and it goes back in the to-do, but when we close that issue, it will move automatically into the done. So perhaps I can just demo that quickly. Let's see if I can close it from there. It should have moved into the done column. Yeah, so we can see it's moved over there. So there's all that kind of automated stuff for you. So I'm definitely keen. Been trying to get various teams using it. Perhaps you've been in a call where I've discussed this already about sort of, okay, we've got fairly far on in this project now, but we've got lots of clear subtasks. Let's use this to organize things and just keep track of things. And there are tons of project management pieces of software out there. This is a kind of a fairly bare bones, but I think relatively intuitive set of project management tools that just go on top, a little layer on top of the rest of the organization principles with GitHub, the issues and things like that. Okay. So, the summary is, we've looked at all of these things, this idea of having the sort of the hub and the spokes. The spokes are the local commits and your forks. The hub is having this central repository, which is organizing everything around that people that can then go and look at. At the end of the day, when we're doing science, we want it to be useful for others. We want people to be able to stand on our shoulders and reuse things. So I think it's really exciting that over the last 10 years, these sort of software engineering tools have become really popular in science. And it's really great when you're reading a paper and you see, oh yeah, okay, here's the link to Zenodo, and the Zenodo tells you which release from the GitHub it is, and you can go and get that specific code that was used to create that paper. Yeah, that I think that's exactly what we should be doing. It helps people then take what you've done and reproduce it, repeat it, build on it, and go on from there. So using all of the principles we've talked about today will then help you as a team sort of use the interface effectively. So we saw that issues PR's project board as the sort of high-level Git organization on top of the low-level Git software. And yeah, just I think keeping these ideas of having that accountability and traceability within a team, especially when we're working on deadlines and things get sort of stressful and you need to sort of work out what people have done and why. I'm often sort of with students will use it for writing papers as well. It works great with LaTeX. If you're a LaTeX fan, it doesn't work so well with Word docs because the Git merging works based on sort of the textual format. So binary formats, it's not good at merging. But LaTeX it works really well with for writing papers. So this was really the sort of the part one. The things that will go beyond this is then later in the week the looking at code review and talking about practices in code review. How do you review each other's code? Do that effectively. We'll also talk about pair programming, which is a particular style of working together. And Ben later in the week is going to talk about GitHub Actions, which is a system for having the continuous integration and deployment techniques done for you automatically in GitHub, which is really nice. Okay, so that's all I have for this workshop, but if there's things you want to do